Hello everyone and welcome back. I'm Mr. Cobalt, and in this video I'm going to be going over the steps in how you can write a Lewis dot structure. Now this is going to pertain to the molecular substances. So all this is going to talk about with regard to molecular substances, also polyatomic ions. This will apply to anything that has a molecule that has a charge. Okay, so what are the steps? The first step is you need to find the total number of valence electrons. So you look up all the atoms that you have in your particular molecule or ion, and you look up their valence electrons for each atom in the ion, and you add them together. Okay. If you've got a molecule that has a positive charge, then that means that you're going to have less electrons that you normally would have with your total valence electrons. So let's say your polyatomic ion has a +2 on it. Well, that means that you have 2 less electrons than you normally would have from your total. So once you get the total number of valence electrons, you subtract out 2 from that total, and that's the amount of number of electrons that you have. If your polyatomic ion, for example, has a -2 charge on it, that means you have 2 extra electrons than you normally would have with your valence electrons, because the valence electrons on your periodic table are pertaining to neutral atoms. So if you've got a charge, then you don't necessarily have neutral atoms. So if you've got a positive charge, then you're going to take that number of electrons away from your total. If you've got a negative charge, then you're going to add that number to your total. And then whatever you're left with is the total of valence electrons for your molecule or your ion. Okay, so that's the first thing. And the reason that's important is because the valence electrons are going to be the ones that you're going to be using to put the molecule together. So it's like the glue that holds everything together. So you're not allowed to use anything outside of the total number of valence electrons. Once you use up all your valence electrons to put the molecule together, you can't add any more. So that's the first step. So the second step is you need to draw a skeletal structure. And the skeletal structure is basically just bonding the atoms together with bonds, right? So you're going to add single bonds to each atom. So you're going to basically put it together in a structural form. And so basically, most of the time, you're only going to have one central atom. But there might be times where you're going to have more than one central atom in a problem. I'm going to go over many examples. So most of the time you're going to have one central atom. So you need to figure out what the central atom is, because all the other atoms are going to be bonded to that central atom. So some tips are, the central atom is usually the one that's written first. Not always, but usually the one written first is the central atom, except for hydrogen. So if you have hydrogen first, it's usually an acid. Hydrogen is never going to be the central atom, because the hallmark of a central atom is it needs to bond multiple times, because all the other atoms are bonded to it. Hydrogen only bonds once, so it's not going to be a very good central atom. So ignore hydrogen. There are other atoms that aren't going to be central atoms either, but we'll get to that when we do some examples. It's the least electronegative atom. So the least electronegative atom is usually the first one written, right? Again, not always. But the least electronegative atom is the one that's going to be your central atom, usually. And then another thing you could look at is the number of unpaired valence electrons in the symbol, in the Lewis dot symbol, right? So usually, because we want a central atom that's going to bond multiple times, that atom that has more unpaired electrons is going to form that many bonds. So an atom with 4 unpaired electrons is probably going to be the central atom, compared to that atom that has only 3 or 2 unpaired electrons. So these are a few ways in which you can figure out which one is the central atom. And then you're going to put, once you figure that out, that one's going to be the first one, and then you bond the others to it. and then you can draw a line. So like this, you have A, and this might be my central atom. I have a B here, a B here, a B here, or a B here. So that would be something like that. This would be my skeletal structure. So once I get my skeletal structure together, then what I need to do is I need to subtract out from my total valence electrons the number of electrons I used to create the bonds. And remember, each bond is 2 electrons. So each line has 2 electrons. So if I have 4 bonds, that means I used up 8 electrons. So I would have to subtract that 8 from my total that I began with, and then what's left over is what I have to use. Okay, so that's the second step. The third step is if I have electrons left over, which most of the time I will, you're going to put lone pairs on the outer atoms first, not the central atom. You're going to put them on the outer atom to give them an octet. So you're going to put lone pairs on the outer atoms to make them have 8 electrons. So if you have an atom, if you have an outer atom that only has 1 bond, then you're going to give that 3 lone pairs to give it an octet. So you're going to give all the outer atoms an octet with your leftover valence electrons. And again, you're going to subtract that from that number of valence electrons that you used to give those atoms the lone pairs. You're going to subtract that from the total. Now, at that point, if you have any electrons left over, those electrons, you're going to put them as lone pairs on the central atom. Okay, so if you've got any electrons left over, you're going to put lone pairs on the central atom so that it can get an octet. So you're going to make sure it has an octet. But all those electrons are going to be going on, whatever you have left over is going to go on the central atom. So if you don't have any electrons left over, then you're done, and you need to check your Lewis dot structure to make sure that everyone, every atom has either an octet or a duet. If you do have electrons left over, then you put those electrons on the central atom as lone pairs, and then after that you're going to go to 5, which is check the atoms in your molecule. Check them in your Lewis dot structure. Make sure that each atom has an octet or a duet. If it's hydrogen, it's going to be fine with just 1 bond with a duet. So if it's not hydrogen, if it's usually all other atoms are going to have an octet. There's a few exceptions, which we'll get to in examples. So if you check and everyone's good with either a duet or an octet, then you are done. You have your Lewis dot structure. We'll talk more about like resonance structures and things like that, but that's in a few steps later. If you don't have an octet, like if one of your atoms does not have an octet and you do not have any more electrons to give, then you've got to do something else. You're not done yet, because you need to make sure that all your atoms in the Lewis dot structure have an octet or a duet. Okay. There could be an expanded octet, like you can have more than 8 in your central atom, but we'll get to that later. So right now we're just making sure everyone has at least 8 or 2. If there's an atom in your Lewis dot structure at this point that does not have 8, then you need to go on to next steps, unless it's an exception to the rule. Again, we'll get to that later. So in the next step, which I will get to in a moment. So welcome back. So the next step, so we've checked our Lewis dot structure, and it turns out that in a case that we're thinking of, let's say, for example, that we now have a Lewis dot structure where one of the atoms does not have an octet, but we don't have any more electrons to put in there. And it's not one of the exceptions. There are exceptions where you don't need an octet, but in those will be exceptions we'll talk about later. But let's say that it does need an octet, but in your molecule, in your Lewis dot structure, you still don't have an octet for this particular atom. You have no more electrons, so you can't put a lone pair onto it to give it an octet. So in that case, the only alternative you have is that you're going to need to take a lone pair from an outer atom or multiple outer atoms, and you're going to have to move those lone pairs in between the atoms to create a double bond, an extra bond, a double bond, or a triple bond. So you might have to do this once, you might have to do it twice in order to make it so that atom has an octet. Once that atom has its octet, you verify again that all your atoms have an octet and a duet. And if everyone is fine with a duet or an octet, then you know you're done and you have a legitimate Lewis dot structure for this particular substance. So in the next few videos, I will be going over several examples of how to work out the Lewis dot structure of various compounds and polyatomic ions. So that way you can get an idea of how to go through these steps. I hope this video was helpful. If you like this video, make sure you hit the like button, hit the notification bell, as well as hit the subscribe button so you can subscribe to the channel, and make a comment in the comment section. Let me know what you think and if you have any questions, and it also feeds the algorithm. So thank you very much, and I'll see you next time.